Okay guys, I'm just going to go through one last acceleration problem. This one might be a little bit more difficult just because we're not going to be looking for acceleration this time. But yeah, it's still not too difficult in the end. So when you're doing a problem like this, again, like the last video I was showing, that as soon as it says acceleration, or accelerates, I know that I'm going to be using this formula. Acceleration is equal to Vf minus Vi over t. Okay, so I'm going to start to look for each one of these things. I'm going to look for acceleration, look for Vf, look for Vi, and look for t. So the way I do it is I write a little table on the side. And this is the way I'd like you to do it too, and I'll give you a mark if you do identify everything. So make sure you do. That's for you guys to get extra marks. So your acceleration, this time we do have an acceleration, and it is 3.00 meters per second squared. So 3.00 meters per second squared. I'm just going to write down the rest of everything I'm looking for. So Vf, Vi, and t. Those are the possible things I could have. So our Vf, well, we don't have that. It says, what is the velocity of a car at the end of the 4 seconds? So if it's at the end, that's my final velocity. That's the thing I'm looking for. So I'm going to put a little question mark there saying that's what we want. Our Vi, again, like last question, we don't have a number, but it does say that it's starting from rest. So make sure you guys, this should set off alarms as soon as you see the word rest. Whoop. As soon as you see the word rest, it is telling you that it's starting at 0 meters per second. So velocity is 0 meters per second. Our time, this is an easier one for people to recognize because we measure time in seconds. As soon as you see that S, you know that that's your time. 4.00 seconds. Okay, now what we want though is we want Vf on its own, our final velocity on its own, because that's what we're looking for. One thing that is going to make this question a whole lot easier is that our Vi, this, is actually equal to 0 meters per second. If that's equal to 0 meters per second, I don't really need it there at all. That's equal to nothing. That'd be like minusing nothing. So I'm going to just get rid of that because it's equal to 0. That made our equation a whole lot easier. I'm just going to rewrite this a little bit so it's a little cleaner. So now what we're left with is acceleration is equal to Vf over t, over time. So now, if we remember our little rule, if it's on the bottom of this side of the equation, we can just move it up to the top of that side of the equation. So now we're left with t times acceleration is equal to final velocity. So if I fill those in, my time is equal to 3.00. Oh, sorry. My time is equal to 4.00 seconds. My acceleration is equal to 3 meters per second squared, because remember we do acceleration in meters per second squared. Is equal to Vf. Okay. 4 times 3 is equal to 12. So our answer would just be 12 meters per second. But that being said, we do want our correct significant digits. So our correct significant digits, I'm going to look back up to the question and say, okay, there was 3 significant digits in this one, 3 significant digits in this one. 3 is as small as we get, so my answer needs to have 3 significant digits. 12.0, that would be 3 significant digits. So 12.0 meters per second is equal to my final velocity. And 12.0 meters per second, we also want to say the direction I was going in. So it's accelerating in the west direction, so it's still going to be going in the west direction. It's going to be 12.0 meters per second west is what is equal to my final velocity. So that would be my answer.